All right, so flip to the back of page of those notes 4.8. See at the bottom you've got some space. I would like for you to draw in this rectangle and then draw in one a little bit bigger, like that. So draw in those two rectangles. Make this side here be 5. Make this side here be 3. All right, is everybody good so far? All right, now, between this one and that shape, we're going to make this one be similar, okay? If I wanted to make these sides be similar to this one with a scale factor of 3 to 1, if this side was 5, what would I be doing? What would this side right here be? 15. So a scale factor of 3 to 1 means it's 3 times bigger, right? You guys with me on that? So you guys agree if I multiply that by 3, I get 15. If I multiply that by 3, I get 9. So if we were writing down the scale factor now going backwards, if I took the 9 and put it over 3, what would that reduce to? 3 over 1. If I put 15 over 5, that will reduce back to still 3 over 1. Everybody good on that? All right, now inside here, we're going to figure out what the perimeter of this shape is. Okay, perimeter is the distance around it, correct? So if this is 5 and that's 3, what's this side going to be? Still 5. This side's still going to be 3. So we take 5, 3, 5, and 3 and add them together. We get 16, and we're going to make those inches now. That perimeter would be 16 inches. Okay, then let's do the same thing with the bigger one we made. If we take the perimeter of this shape, 15, 9, 15, and 9, and we add those up, do we get 48 inches? We'll make this inches also. Okay, is everybody good with that so far? All right, so this one over here has a perimeter of 16. This one over here has a perimeter of 48. How does that compare if we look at our scale factor? So what I mean by that is if I took that 48 and 16 to figure out the ratio between those two, what's it still going to reduce to? How many times does 16 go into 48? 3 times. Do you guys agree that it's still 3 over 1? Would that make sense? The ratio shouldn't change when you're doing perimeter, should it? Okay, so what we've just figured out is this. If you know a scale factor, the ratio of the perimeters is going to stay the same. So whatever the ratio between the sides, that's going to be the ratio of the perimeter. Now, but watch what happens if we do area. What would be the area of this rectangle? We would do base times height, right? 5 times 3 is 15, so that'd be 15 inches squared. The area of this one, if I do 15 times 9, that's 135, isn't it? Make sure I did that right. Okay, so my question to you is, when I look at those, that's not a 3 to 1 ratio, is it? Do you see any type of pattern, though, that could be here? If I take the 135 and I put it over 15, what does that reduce to? Somebody tell me. 135 over 15. We just did it over there, but what do we get? It's 9, isn't it? How does 3 compare to 9? Three squared would be 9, wouldn't it? Okay, so what we just discovered was the fact that the area ratio is going to be whatever the scale factor ratio was squared. And if you think about this, area is squared, isn't it? So it should fit that it ends up working that way. Okay, now let's do this an example where you could work something out. Look back up at the top. Okay, what is the scale factor between those two shapes on number 6A? Oh, shoot. You guys agree it's 5 over 8. Let's write that down. So in 6A, what is their similarity ratio? It's 5 over 8. I just put the two sides. So if they ask you what is the ratio of their perimeters, will the ratio change? Nope, it's going to be the same, 5 over 8. But if they ask you what's the ratio of the areas, now I'm going to take that 5 over 8 and I'm going to square it. So I'm going to take the 5, square it. I'm going to take the 8 and square it. That will tell me the ratio of their areas. So perimeter stays the same, area gets squared. Okay, now if you're wondering how this is going to help you, go down to number 7. Okay, on 7A, it tells us that the trapezoids are similar. That means they're proportional. The area of the larger trapezoid is 121 meters squared. We want to find the area of the smaller one. So what is the ratio between the two shapes, CR 12 and 18? Let's put those together first. So the scale factor between the two is 12 over 18, which reduces to 2/3. So that would be the ratio between the two. Well, we're going to work with area, correct? So we're going to take this ratio and square it. Instead of using 2 over 3, we're going to use 4 over 9. 2 squared is 4, 3 squared is 9. Now, when I go to set up my proportion, if they tell me that 121 meters squared is the larger one, is it going to go on top or bottom? Since 9 is larger, it has to go on bottom. Wouldn't go on top. Now I can cross multiply to find the area of the missing shape. So here's what we did as a recap. We figured out that we put the 12 and 18 together. That's the two sides they gave us to get 2/3. That's the area. That's the scale factor. The ratio between two sides. We must square that to find the ratio of the areas. Since we know the ratio of the areas to be 4 over 9, wherever this one is, it's 121 meters squared for the bigger one. Since 9 is bigger, I put it on bottom, x on top. Now I cross multiply. Divide by 9. And I figure out what x is equal to. That makes sense, everybody? Okay, let's pause. Let me go over the other one, then we'll see if we got questions. On 7B, if they want to do perimeter, now I don't square 2/3, I use 2/3. Perimeter ratio stays the same. So on 7B, it says the perimeter of the smaller trapezoid is 34. 2 is smaller. I'll put that on top. X on bottom. 2x is equal to 3 times 34. X will be 51. Okay, you guys try the last one down there, and we'll go over that one together.